For my project, I decided to work with quasars to learn more about these mysterious objects. When going through this tutorial, I came across graphs such as these that plotted the wavelength emitted against flux for different objects such as stars, galaxies, and quasars. However, it is important to be able to see not only the wavelengths that the object radiates, but also how brightly it radiates at those wavelengths, and magnitudes under different filters can give a simplistic yet comprehensive value to work with. After completing the tutorial, I obtained this data set, which gives 1,000 quasars, their magnitudes using the ultraviolet filter, representing a wavelength of about 374 nanometers, the green filter, G filter, representing a wavelength of around 487 nanometers, the R filter, representing a wavelength of around 625 nanometers, and the far infrared, or Z filter, which represents a wavelength of around 890 nanometers. The tutorial had me plot the magnitudes of quasars in the U filter versus the G filter versus the R filter, and the R filter versus the Z filter, I mean. It also had me plot magnitudes versus the redshifts, just the Z value. I was curious, however, to see if there was any correlation, any pattern, between the differences of magnitudes. For example, was the value of U minus G somehow related to the value of G minus R for quasars? After the tutorial, I had obtained this data set which had all of these magnitudes as well as the redshift. I decided to write a program that would put, for example, U minus G on the x-axis and G minus R on the y-axis, and assign different colors based on the redshift. Those quasars with a redshift less than 0.9 were green, those with a redshift between 0.9 and 1.8 would be blue, and those with a redshift greater than 1.8 would be red. In this program, I imported all the data into different arrays, as shown in this program here, and each array represented the U filter, the G filter, the R filter, and the redshift. Then, I converted the data into float values from the string values to allow subtraction of magnitude values. Then, I subtracted the magnitude values, and using a code here, I plotted different ranges of redshifts in different colors. 0 to 0.9 was green, 0.9 to 1.8 was blue, and anything over 1.8 was red. And I obtained this graph here. Based on this graph, I noticed that most quasars had up to a 1 magnitude difference between filters for both sets, the x and y axis, and most of these quasars are located here, in this area. However, there are a fair amount of outliers over here. And for the outliers, when the difference in magnitude is greater than 1, most of the quasars are entirely red. This seems to indicate that as the differences in magnitudes increase, it signifies a greater redshift. A greater difference between magnitude, in short, is present in quasars only with a higher redshift value, over 1.8. I also noticed that those quasars with a high U minus G value, going right on the x-axis, also had a relatively high G minus R value, going higher on the y-axis. And I predict that it's related to the way that the high redshift broadens spectral lines. If redshift can broaden spectral lines, it can broaden the range of wavelengths emitted, so it can increase the differences in magnitudes of different filters across the board. A trend line with a slope of about 0.5 would make a good best fit line. This would show that as G minus R increases by 1/2, U minus G increases by 1 magnitude value.